The devices are connected either to one another or to the internet. The possibilities of interacting with one another, and they can have the possibility of sending and receiving data through the internet or through other kinds of networks. So it doesn't have to even be the internet, even though it's the Internet of Things. At its simplest, internet is, for example, SuomiConnect's Dinksi service, which is IoT for consumers. Se on IoT sulle, mulle ja mummullekin. So it's made to be extremely easy. You can order a sensor from the internet, and then it arrives, and then you can see, for example, here is the air quality in our office. You can see VOC, CO2, motion. There's nobody at our office today. Battery voltage, light, and the air pressure. So that's a simple use, or a simple example of IoT. A little bit of the history on IoT. It has been existing already since pretty much since computers came around, or even since telegraphs came around. But in 1982, some fellows from the Carnegie Mellon Institute, or university as it's called today, they decided to connect a Coca-Cola machine to their precursor of what would become the internet. So then it was called ARPANET, and they were able to see how many Coca-Cola cans are there in the machine at a certain time, and then they were able to automatically send a message to order new Coca-Cola bottles from the stocker when the machine was almost empty. In 1999, Kevin Ashton, a researcher and electronics and programming developer, he came up with the term IoT, and then that was then translated to esineiden internetti. Around 2004, IoT started to become a relatively well-known concept, and has been quite quickly expanding from there. In around 2025, it's expected to be around 75 billion IoT connections, and around 2030, it's expected to be around 150 billion IoT connections. So it's growing extremely fast at extremely high rates, and it will only grow faster. But the key will be for everyone to maintain control over their data. And then we get into how does it work. Here we see a chicken coop. Here's a couple of our chickens. Then inside of the chicken coop, there's a sensor that is measuring, for example, the temperature. This specific sensor can measure the temperature for 20 years, and measuring and sending 1 time per hour without ever requiring a battery change or any other maintenance. From here, the Lorawan signal is going to the tower, which has a gateway on the tower. This is operated by the Digita, who is running our national radio and television and the national Lorawan network and all the towers. But Digita is now a private company that is owned by the Americans, because it was very smart of the government to sell all those towers to the French, and then the French sold them to the Americans. But so the data is going forward from Digita's application server to our server and our Tinksi pilvi, or SuomiConnect IoT cloud, and from there in different forms and through various interactions to the different users. So there is actually IoT consists of many different technologies, many different protocols. Almost all of them, including wireless communication. A lot of IoT that does go over LAN connections and other wired connections such as fiber. But there is this matrix shows the kind of the difference where these different kinds of IoT protocols and methods sit in the range. So RFID, NFC, this is very short range, usually passive devices. This is from NFC is usually requiring around 2 centimeters, 1 centimeter ranging. Then different kinds of RFID devices can then go, for example, rain RFID up to, for example, 60 meters. Then we go to Bluetooth, BLE, that's Bluetooth low energy, that you can go around 30 meters. And then we start getting into these different wireless Wi-Fi and Zigbee, and then we go to 2G, 3G, 4G, 5G, and these are for 2G, 3G, 4G, 5G. These are all these mobile systems that everyone is familiar with, and here's the different Wi-Fi standards getting faster and faster through improvements in both hardware and the firmware technology that is used in them. But then LPWAN, so this is low-powered wide area network, is used for maximum range with minimum consumption of power and also minimum bandwidth. So you don't want to send you don't want to try to send pictures or videos with using LP1. And then now lately there has been coming more VSAT, so and a combination of VSAT and LP1, so hybrid systems combining terrestrial LP1 and SAT communication. Today we'll be focusing on the LP1 protocols. As I was saying, it's a low-powered wide area network, and more specifically on Lorawan, because that's the one that we are using. There are three main players, or I guess you could say four, because NB-IoT and LTE-M are almost kind of competitors now, even though they were started by the same people originally. But so Lorawan is using ISM bandwidth. It's the frequencies are from 863 to 928 megahertz. Sigfox is using ISM bandwidth as well, 862 to 928 megahertz. And then NB-IoT and LTE-M, these are narrowband IoT, which is using 3G connections, and then LTE-M is using 4G connections. So these are using the satellite systems. And they all, Lorawan and Sigfox, they have their benefits over the cellular systems, but the cellular systems also have their benefits over the LP1 systems. And the ISM bandwidth, or taajuusalue, it's lisenssivapaa, so license free, and it stands for industrial, scientific, and medical. License free doesn't mean that you can do whatever you want. There are a lot of technical limitations that are set into place by different countries. For example, how much power you can use and what kind of dBm rates you're allowed. So what kind of link budgets you're allowed. And the reason why we went with Lorawan is because it's the most widely adopted LP1 protocol in the world. Or Lorawan is actually, it's a kind of a standard or a specification, and it's an open standard, open specification, meaning that anybody can use them or build Lorawan devices that work within this specification. It is highly recommended to have systems and devices certified by the Lorawan Alliance, but it's not mandatory. One of the reasons why Lorawan grew over Sigfox so much, even though they both came from France and both came from originally the same area in France, is that Sigfox tried to be proprietary and maintain their own control over the system for a much longer time and make money at an earlier stage, while Lorawan made things open a lot faster. And when things are open and free compared to when you have to pay for something, and they're both doing actually around about the same thing, then obviously it's going to grow a lot faster. There are both Lorawan and Sigfox networks in Finland, although the Sigfox network is a lot smaller and mostly located in Helsinki and Turku area, a little bit in Tampere, while Lorawan is covering the whole of Finland.
Also the Tampere region.
Sorry.
Sorry. Lorawan covers also the Tampere region where the Sigfox is.
Yes. Lorawan covers all of Finland, including Tampere.
Yeah.
Yes. So then there are also the amount of Lorawan devices that are sold and deployed compared to the amount of Sigfox and compared to the amount of NB-IoT or LTE-M. It's Lorawan is greatly leading the way. So here I'm just showing, here's a very good resource on LoRa. Semtech is the company that actually owns the rights now to LoRa. Surprise, surprise, it's an American company, and they bought the rights from the French company, or the American company bought Semtech from France. So this is a very good good resource on Lorawan. There's lots of information on different applications and why use LoRa. So normally it's talked about, for example, the range of LoRa being around 10 to 15 kilometers, but that is comparing to 1 kilometer for 3G or 4G, but that's in city, so in a congested city conditions. But when you're in Finland, you're not very often in a congested city conditions, and then your range for Lorawan is the theoretical maximum range of Lorawan is 800 kilometers, but the longest measured and verified Lorawan communication on this planet has been so far 832 kilometers, but we have experienced very often sending over 50 kilometers, 75 kilometers when we have been involved in different projects. So I'll just jump to another great great IoT resource, Thinksy.fi. So that's just our kuluttaja IoT, our consumer IoT system. But my goal of coming here, seems like my computer is going very slowly right now, or my internet. So here we can see the coverage here in Finland, and here we see if we go to ulkokuuluvuus, so that's coverage outdoors, we see that everywhere is covered now. But then we go to sisäkuuluvuus, so that's indoor penetration. Then we see that there are still areas in Finland that are not completely covered with indoor penetration. But for example, if we look here, then if we are selling a sensor to a customer in this area, then we tell them that they can try it, and if it doesn't work, then they can just send it back. But the network is it's constantly growing, and all of the sensors that are connected are sending connection quality information to Digita, and then they are able to use that connection quality information to improve the network. Yeah, now we actually came to the break already, but so does anybody have any so far on any of the IoT protocols or the LP1 or NB-IoT, LTE, RFID, NFC, any of these? Does anybody have any questions so far?
Well, one question about the Lorawan thing. How about the coverage and availability abroad? How was the technology? And
yes, so
yeah,
there is a coverage in around 65 countries so far for Lorawan, and it's growing quite quickly. But then the good part about the Lorawan is that even when there are no existing national systems, it's very easy to set up a network. The cost of the gateways is relatively low, and then the power consumption required by the gateways is quite low, and then the range being so great, it's possible to cover various countries and with a relatively low amount of gateways. But so that's actually one of the disadvantages in some countries of LP1 compared to, for example, NB-IoT, is that almost every single country has now cell phone coverage. But since LP1 is a lot newer technology, then it's obviously still in the growing phase. But and then another point to that question is that when going from country to country, the different in different countries there can be different frequencies used, or different regions. So Europe has 868 megahertz. US has 915 megahertz, and there's also 915 megahertz in Australia, and so that's one factor that has to be taken into account. But most device manufacturers are now building their devices, and also the chip manufacturers are building the systems so that you can configure which country the device will be deployed in using either firmware settings or even over-the-air settings changes. So even that problem has been slowly disappearing. And then also there's the problem of roaming between the different network operators in different countries. So the Finnish Digita Lorawan network has now roaming agreements with I think it was seven different countries, but that's not enough to be able to take your device anywhere in the world yet.
Okay, good.
But for that, if like in the case that you want to use a device anywhere in the world, for that we have these we have agreements with satellite providers such as Argos. That's part of the French national space program. We don't have our own satellites here in Finland yet, so we can't make an agreement with the Finnish national system.
Good, thanks.
But should we take just a 10-minute break and then continue?
Yes, okay. Is it okay that we continue at 9:55?
Sure.
Yes, let's meet then.
Yep. Thank you. We see you at 9:55.
Yes. Hi, I asked in the chat that, or told that I'm recording the workshop, so if anyone has issues on that, please tell. But I think we can continue.
Okay, so can you all see my screen again?
Yes.
Yes.
Yep.
So the next thing I thought I would touch on is IoT in cloud versus on-premise, or also known as private networks or closed networks. There's a lot of customers, in a lot of different segments that they don't want their data to go flying up into space and then traveling around the internet and going to some server somewhere in the world. So they would prefer to have their own servers, their own closed network, their own gateways, which are mounted on possibly their own towers, and all of their own application servers and own back-end and front-end software. And so these kind of customers are often, for example, military customers, some civil authorities, some police, for example. Although the security on with, for example, Lorawan is the security level is very good. It has 2-level AES 128 encryption. It's obviously not infallible. The weak point is usually the users. The people that are using it are the easiest way to get the data or get access to the system through all these kinds of different phishing campaigns and other cyber attacks that we've heard of lately. But if somebody really does want to try to take on the encryption and the hack into the actual devices, it is obviously possible, but it requires a very large amount of energy and time and skill and possibly resources. So it's actually been found that a lot of the cloud-based systems are just as safe or safer than the private networks. And the possibly safer comes from the fact that cloud-based systems often have people who are monitoring their networks and their servers, application servers and systems for different kinds of threats and attacks, while usually people that are running private networks, they just assume that they are safe because they are relatively disconnected, but then often there comes a leak somewhere along the line. And so like the main difference obviously between the cloud IoT systems and on-premise is that on-premise, everything is, you have your own stuff, everything is there. On cloud means that it's in the cloud or in a cloud, and you don't really require much hardware. So on-premise systems have a lot more hardware costs, while on on cloud systems are a lot cheaper to get started, at least. But then often with on-premise systems, you have a reduced cost of running the system, and that can be very sensible in the case that you have in a relatively small area. If you have thousands of sensors, and you don't want to be paying €2 a month for every one of these sensors. And then in that case, you would definitely go with either on-premise or a hybrid, on-premise with cloud backup or functionality. Then you always have to think with the cloud systems that where is the data being stored and whose data. So, for example, we store all of our data with a Finnish company called UpCloud, and we use both servers in Helsinki and in Frankfurt. So we have backup redundancy in case one building burns down, the other building will be standing. Yeah, and then another 10-minute break, but maybe not yet. So now we'll start a little bit of talking about the actual use of IoT. Where can IoT be used? What can it be used for? There's obviously the IoT sensors, many different kinds of sensors. Anything that you can measure. Well, almost anything. Most things you can measure with IoT sensors, but you can add IoT communications capability to almost any kind of existing sensors. And this can be done through different protocols such as Modbus or 4 to 20 milliamp. These kind of standard industrial protocols, or electronics bus protocols, such as I2C or these other electronics embedded integration bus protocols. I'll just show a few sensors, what they look like. So does everybody see me now instead of the presentation?
Yes.
Yeah.
So first I'll show a couple gateway examples. These are indoor gateways. This is a small indoor gateway from a company called Tektelic. So this is connected either with LAN or with Wi-Fi, and then you can connect your sensors. This gateway is connected to a network server, and the network server is the software that is handling the data and then sending it to your backend. I'll show you the network server application in a few minutes. Here's another a slightly larger, slightly more powerful indoor gateway from a company called Multitech. Tektelic is a Canadian-Ukrainian company. Multitech is an American company. There on the testing board on the wall, you might be able to see another even larger Multitech gateway here. So a few examples of some of the sensors. This here is a temperature and humidity sensor, and also door or window sensor. So this device has an integrated battery. It's not a replaceable battery, and is rated IP68, so you can put the whole thing in the water and it will not get damaged. But this will measure temperature, humidity, and the position of a door or window or similar kaappi, if it's open or closed, for about 10 years, and then it's just simply recycled. So the electronics is getting quite small if you consider this is also including the batteries.
Is that in the Metsäsairala compost?
No, this is not in Metsäsairala. In Metsäsairala, we are using a larger larger sensor that looks more like this. So this, except the Metsäsairala system has a integrated sensor, integrated antenna. This device here is now set up for some research that we are doing with a company in Holland, in Netherlands. So I'll be installing this out in the field one of these days. Here you can see. So here you can see this hautaristi. This is one of the this is a prototype of a more advanced sensor with more functions for Metsäsairala. But you see this this will contain the actual transmitter is mounted on top of this 2-meter high stainless steel construction, and then there are also sensors in here, and there are also sensors down in the tip of this, and that they are using for measuring different things in the composting process. So they're measuring. Currently, they are only measuring the temperature down at 2 meters depth, and then they are measuring the temperature, humidity, and air pressure in the ambient air. Here's an example of a Lorawan water meter. So this meter is designed so the battery is lasting about 16 years. But because the laws were written according to the old style meters that actually had clockwork inside of them, and that clockwork would start to lose its accuracy around 10 years of age. So even these have to be replaced every 10 years, even though they last quite a bit longer. And this is using ultrasonic flow measurement. So this is sending how much water is going, flow rates, as well as monitoring for alarms for if the water temperature is too low, like below 3 Celsius, so there's a freezing risk. And if the water is flowing in the wrong direction, there's a contamination risk. Or if there's a burst in the piping. Here's one example of a sensor that is used in, for example, some grocery stores. They are measuring the temperature and humidity in the kylmäkaappi, lihatiski, and all these. And then these kind of IoT systems are very, very good for setting up building and indoor air quality monitoring systems, because with traditional building automation systems, it would cost around 1,000 euros per room to set up monitoring of the indoor air quality. And now with IoT systems, one sensor like this can measure all the air quality parameters, and this sensor is installed in 5 to 10 minutes per room, compared to several hours of installation work with traditional building automation. And then we have some extreme, some devices for extreme conditions. So these are two temperature sensors that are IP68 and very rugged. So they are shock-proof, waterproof, pretty much everything proof. And one with a sensor just right there, and one with a sensor on a 1 meter cable. And then there's many different kinds of GPS devices. Here is one of the larger ones. This has 5 years battery lifespan with 3 normal AA batteries. And then we have there's also lots of smaller sensors for GPS tracking. This one, for example, has 3 years lifespan, and that's if you're sending once per day, or sorry, twice per day when it's standing still, or every 10 minutes when it's moving. And then there are, for example, the exact same sensor inside, but this device is made for putting on a collar of a large dog, or for example, a reindeer or a cow, so that you can track the animals where they are going. Or your kids, depends on what kind of kids you have. And here's another example of a, this is a temperature, humidity, motion, and light value, so luminosity sensor, which is the same as this here, except this one is obviously quite a bit smaller. This one has a battery life of approximately 10 years. This one has a battery life of approximately 5 years. And then there are different versions of this sensor here. For example, this one also has a CO2 measurement. And then for doing site surveys, there are sensors like this that are designed for just measuring the signal quality and seeing what kind of signal quality you can get. And there are also lots of different kinds of metering sensors. For example, this one here, this is reading the blinking LEDs on a power meter, and then sending the count every hour. And those can be used for many different metering purposes. So does anyone now at this stage have any questions about these actual sensors? before I go on to talk more about the different uses of these sensors. Oh, sorry, I had a couple more nice, scary-looking sensors here. So this is a sensor example for measuring moisture and the conductivity of soil. This is a kind of a very high-end moisture and conductivity sensor. And there are also a lot of cheaper sensors available. So this sensor actually gets connected to a transmitter to form the combination. But so does anyone have? Oh yeah, sorry. There was also this one's quite interesting as well. So this is a ultrasonic level detector. So you can measure the level of the, for example, how much grain there is in a silo, or how much you have in a lokasäiliö, for example, and you can get an alarm when it's getting time to be emptied out. And we have many other sensors as well, but I'm not going to go through all of them. But did anybody have any questions about?
I do have, if I may ask.
Sure.
So you showed us so far quite a lot of sensors that they feel raw data, basically. Like, what's your take on the sensors that collect like image and movie and data for these applications, like to monitoring traffic and to count number of people, like anything that it's collecting, either picture or a film? What's the usual standard when you pass to the professional level? So, like, is it a GoPro professional enough, or what do you recommend?
Yeah, no. So actually, what I recommend for these kind of for people counting or traffic counting or these kind of things, when you use an actual camera such as a GoPro, then you run into problems with permissions and GDPR. So these problems are solved with using edge devices. So these are camera devices, low power camera devices that are processing the picture data right in the camera, and counting the actual people, counting the cars, for example. It's identifying identifying what it is seeing, classifying it, and logging it. But it's not saving or transmitting the video pictures, because once you start actually transmitting the video pictures forward, then you start running into the problems with the GDPR and having to have all the warning signs of the cameras and all these rights and complaints.
Yes,
So,
I understand. Yeah. And just a continuation of this, because I got curious. Sorry for extending so much, but I got curious about this new type of speed radars that you have in Finland now, that they take your average speed, and I was wondering how they can collect this data. So based on what you said, I assume that the camera identifies your car, like read your plates, but doesn't store the picture information. It basically documents where you have passed with your car, the time log, and it sends to some like central nodes that when you pass another sensor a couple of kilometers later, by the difference in time, they can estimate your average traveling distance, so they can find you if on average you are above the speed limit. I was just curious how those, for instance, those new ways of managing traffic, how they handle the data collection and the data privacy, as you raised.
Yes. Actually, when it comes to the actual radar cameras and the speed cameras, because they are authorities, they are actually required to store the actual pictures. Because a lot of people will claim that it was not them or they did not do that, and now they have changed the laws so that that if they cannot identify the driver, it just goes to the owner of the vehicle. But because of the fact that they are authorities, they actually do have to save the actual photos, because people will complain, and then they can show the people, okay, is this not you? But in private or commercial settings, it's much better to use just Edge for actual accounting. You can also use Edge systems for the identification of people in a way that is data secure, so that for example, in a company, you can have a camera that is learning all the employees, and then in the actual edge processing, it's only seeing each employee as a number in the database, and so it's not transmitting any names or other identification, and then it's only sending some certain number forward to the control room, for example, of the security guards, and then the security guards then have their own database, which is then matching that to a certain person, so that the security guards know that, okay, now that person is here and that person is here. And then when the camera sees somebody that it does not recognize, that it will then flag that image, and then the security guards can then take up the actual image.
Yeah, thanks. It's quite interesting, those, like the fine details of what you can do tech-wise and what you can and cannot do law-wise and ethical-wise, etc., etc. I was just seeing yesterday news about Amazon is tracking with cameras the drivers' behaviors, and they were discussing the ethics of this. Is it ethical to track to that level your employees, like if they are driving carefully or not, and how they do during the day, and are you allowed to fire somebody based on that, etc., etc. So this opens up quite many discussions involving the IoT, the AI, and the regulations to such things. So it's very interesting. Thanks for your answer, Marco.
Yeah, no problem. Thank you for the question. I'll just share my screen again. So I'm just falling back on dinksy.fi again, just because there's some nice looking graphics here. Although my whole computer is running quite slowly. So here you see that Dinksy tekee kaiken helpoksi. So Dinksy makes everything easy, and that's how it should be with IoT in general as well. You save a lot of work, a lot of time, a lot of money that you would normally use for running cables and all this other stuff. So here you see puutarhurin pikkuapulaiset and then seurantalaitteet. So this tracking devices is a very popular. It's actually, in terms of sales, it's our most popular application. Earlier, when we started out, we thought that it would be that people would be most interested in their indoor air quality, and that these sensors would be sold the most. But it turns out, when we look at sales numbers, that people are the most interested in their things, and not so interested in themselves. So they want to have tracking in their boat motors. They want to have tracking in their equipment that they're renting out. They want to have tracking on their animals. But we're quite surprised that there's not so many people that actually care about their indoor air quality, even though everybody talks about indoor air quality and homekoulut and hometoimistot and all this mold problems, but it turns out that there's not that many people that really care about that. But people do care about their animals. So when people have animals, they want to make sure that for example, the chicken coop is not too much humidity. The temperatures are not too high. Most chickens in Finland, they don't really care so much about the cold weather. And when you have an insulated chicken coop, the most important thing that you need there is sufficient ventilation. But also in Finland, there's a lot of people that are doing beekeeping or apiary. So one thing that is of concern for beekeepers is that if there is too long of a cold spell, then the beehive will actually die. So they have to go and actually add extra blankets, insulation blankets, over the top of the beehive if the temperature is going too low. Because when the bees are getting too cold, they're using too much of their food storage, and then they will run out of food, and then they will die in the winter. And horses, for example, horses and dogs are very sensitive to too high temperatures. So it's very important to track the temperatures inside of a barn and in other areas where horses and dogs are. They can very easily get heat stroke. And so some people who actually have professional working dogs have bought temperature sensors to mount on the collar of their dog, so that they can see when if the dog is in an area that is too high temperature. But so there's obviously the home gardening, but IoT is expanding at an amazing rate in farming. And one of the biggest farming IoT projects is this FarmBeats, which is from Microsoft. So the largest owner of farmland in the USA is now Bill Gates, and so Bill Gates has the goal of being able to produce enough food to feed the whole world, and so that there's no reason for anybody to suffer. And they believe that when with the sensible application of IoT in agriculture, you can greatly increase the yields while at the same time not depleting the life of the soil. So everybody knows that if you just farm, for example, corn on a piece of field every year, then that soil will no longer have nutrients after a little while. So then you have to call Nanopar and get some of their systems to get the liete and yeah, rich in the soil again. But when you are monitoring the nutrients in the soil at the same time as monitoring all the growth conditions, then you're able to alternate your crops in a way that the soil is not depleted. So then Industry 4.0 or so-called connected factories. It was so earlier that in a factory everything was connected with wires, and everything required wiring. For example, you would connect a sensor to, for example, a temperature sensor to a tank, and then you would pull wires for, say, 100 meters to a PLC, and then you'd connect the PLC to the actual network of the factory, and then that would be connected to a SCADA, so Valovomo system, and from there to MES or other data or production handling systems. But now with the advancements in all the wireless and IoT technologies, you can install a lot more sensors on every single piece of equipment in a factory, with often 1/100th of the cost of the previous applications, and it's much easier to do changes to them, much easier to update them, and yeah, it's made much faster. And then so the result of this additional sensor information, or the additional sensors, is that you get a lot more information. So this information obviously has to be then it has to be added or handled in a way that is sensible, and that's where we will in the second part of the workshop. Ulysses will talk about this. So logistics, in logistics and smart supply chain, there's a combination of tracking devices, so location tracking, GPS tracking and such. Then there is also many different kinds of sensors. For example, when you're shipping food or medicines, then it's required that you know not only the location but also the temperature that they are being stored at, or that they are reaching the whole time. And then also in the actual storage facilities or the shelves, there are used sensors. For example, RFID or RAIN RFID systems, so you can constantly see your live and updated inventory without having to go and move a single box off the shelf or count anything physically. In the application of smart electrical networks or älykkäät sähköverkot, here in Finland we have not had so much problems with the brownout or this problem when there becomes too much requirement for power in a certain area that has too little to offer. But in many countries, in larger countries, and especially in countries where Republicans are ruling with a little bit too strong of a hand, like Texas, there they get a lot of problems with because they have deregulated everything. There are no rules or standards, and now they are just starting to wake up to the fact that pure capitalism with no controls is not a very good thing for continuous functioning of electrical networks and power grids. So now Elon Musk is starting to work with Texas now to provide some backup in the form of a massive battery and solar. So then one other very interesting and very quickly growing application of IoT is smart healthcare or älykäs terveydenhuolto ja vanhusten vapauden lisääminen. So this is the enabling the vanhusten vapauden lisääminen. This is enabling more freedom for elderly people through the sensible use of IoT in a way that a lot of elderly people tend to forget things. So these smart systems can then remind these people about certain things. For example, one of my friends in Norway has developed a pill box that it sees when there's every day of the week has its own boxes, and there are different versions of it. But so it will see at on Monday, for example, that they have opened the Monday slot, and then the sensor can see that the pill or the pills from the Monday morning slot have then disappeared, and then the pill box was then closed. So one can then assume that either the patient or the consumer of this medicine has either consumed it or taken it out and thrown it away. But it's a way of and then if they do not go to take that medicine out of that box, then they are given a reminder, and that can be done in many different ways. And then if they still do not, after that reminder, if they still do not react to that or respond to that, then it can be set up so that, for example, the family or the doctor or a nurse of that patient can then be notified. But there are many different things like that in a hospital. There are lots of things that you want to locate. You want to be able to locate the staff in the case of an emergency. You want to be able to locate the different equipment, beds, and operating systems, and lots of different equipment. So a lot of things in hospitals nowadays are equipped with either Bluetooth location or RFID location systems. And Yeah, so I guess that's about what I was going to talk about for there. I was just thinking that I will show Mari, how much of a background do you have in programming and such data handling and web development?
Absolutely none.
Okay, so I know I don't have to ask that from Ville, because I know he is quite a guru. So I'll just show now the actual application server. So Digita is using system. Oh. Okay, it's always nice to come. So this ThingPark, it's made by a company called Actility, and so this is a software that can be used also on premises or just on a Linux computer, although it has to be a relatively powerful Linux computer. You can't run it on a Raspberry Pi or anything like that, or maybe the newest ones, but. So this is the application server, and this is the system that it's getting the data from the actual gateways or the towers, and then it's looking at this data, and then it's deciding who this data will be sent to. And in this software, there's a logger. So here in the logger, we can see data that is coming from the sensors. So if I put an automatic refresh on there, you can see that there's sensor data is coming constantly from many different devices. All of the encryption information of these devices is not visible in the traffic, but the device EUI, so that is the device identification, that itself is visible in the traffic. And so here we can see universal timestamp, local timestamp, and then here we can see the signal to noise ratio, and then in Lorawan, this SF level. This is so when a sensor is sending SF7, it means that it has a very good, very good connection. That's the best connection that you can have. And then when you have that, there we go, SF12, we see this sensor here. It's telling us that it's quite far away from the actual devices. SF7, it's using the minimal amount of sending power. So these devices have a system called adaptive data rate. and so that they will try to every once in a while they will try to reduce their data rate from SF, for example, SF12. It will try after a couple days to drop it down to, for example, SF11, SF10, and then if it's still getting good connections, it will drop it all the way down to SF7. But then here it's also possible. Excuse me. So here is also possible to see the actual location of the tower that is connecting to. And these sensors, they're all around the place, all over Finland. So they're I would be quite surprised now to see something outside of Finland. But so we are able to use this logger for doing troubleshooting, trying to figure out what is the problem with certain sensor. So here I can show you what this is the actual payload. So this is the data string of a sensor, and then the whole message is sent to our server database, and then it is decrypted in our database, and then it's sent to the various consumers. So for example, the Tinksi sovellus, the Tinksi mobile app, or the other SuomiConnect IoT system. So this is the main system where our professional users are looking at their data. So, for example, this is just today's data. But if we change to, for example, 1 week, and then here we can look at solar exchanger. This is actually from solar heat panels that are mounted on our roof of my house. And here you see that there was some action after I had cleaned off the snow, but now it has snowed again. So now you see the temperature is relatively stable. And so this is not outside, but this is inside where the glycol tubing is coming into the house. There's on our system, there's also the kind of the devices screen, and so you can see which groups they are in. Then you can also go into the settings of each sensor. You can change the names. You can add or remove it from a group. You can set the settings or set the alarm settings. And then you can set, for example, reference lines, so vertailuarvo viivoja. Then you have your alarms screen. Right now I don't have any alarms, but here you can acknowledge your alarms, and you can see your current accepted alarms. And then in the so here we see I have currently two of these sensors. You see one sensor is in our boat out in the yard. The other sensor is here in our house. That's actually the one that I showed you in the presentation. And then it's possible to see the motion or the history of these sensors. So I had this sensor with me on a trip to town, but since it's only sending every 10 minutes, you see from here to or no, this was visiting at a friend's place, so but it's only 10 minutes to drive there, so it sent once here and then once there. And then just an example of the water consumption. So this is most interesting if you have, for example, 1 month's view. So here we can see from the 9th of January to the 9th of March, this water consumption sensor. So this is on address number 1 -3, and then this is L for lämminvesi. And we see that on this day they were using 60 liters, this day 118 liters, 97 liters, 101 liters, and so forth. And so you can then also automatically get these kind of reports into the email, or you can generate them manually like this, and you get the kulutusraportti if you have Finnish set as your language, or you get consumption report in English. Okay, so I guess here we have a little bit of a hybrid. Consumption report up here and then kulutus down here. So it's made very easy for the consumers to get the data. There are also pulse readers for water consumption, pulse readers for energy consumption. So here's one example. You can see 169,000 kilowatt hours this day, 173,000 kilowatt hours, 184,000 kilowatt hours. So this is a massive amount of energy consumption, but this is this meter is feeding the kaukolämmitys for many buildings in Mikkeli. There's also the gas consumption pulse, but I don't have any devices connected to here. And then raportti or reporting system for making more complex reporting, and then also setting up automated sending of reports. So yeah, then does anybody have any questions at this time? No questions right now. So then, if there are no more questions now at this point, then I propose that we go to the next phase, and we look at the actual user case that either Observice or Nanopar could possibly have. And for this part, should we take a little break now in between, or?
Could take a short break, maybe.
Yeah. So if we continue then at 11:05.
Mm-hmm.
And during the break, Ville and Mari can maybe think a little bit through what kind of possible problems or challenges do you have that we could solve with IoT technology? Okay.
Mm-hmm.
So see you then at 11:05.
See you soon.
Okay.
Thank you. Hello.
Hey again.
Sorry, a little bit of kähe kurkku.
Korona se vaan.
A little bit of a cold, yeah. I went to a corona test yesterday and unfortunately I got negative news, or actually fortunately. So at least not on that test, not corona, but but So did you, Mari or Ville, did you have a chance to think of any possible applications or challenges that you could possibly solve with the use of IoT?
Well, I was thinking about the various cases that we have been building in the past and shall be building in the future. From that area, I couldn't think of yet anything suitable. Although I had one personal issue that might benefit from such, but that would require measuring the temperature of the lake water, because we have this avanto here that needs to be kept open. So we have
actually sold quite a few of these rugged sensors with a cable for measuring swimming water, beach water.
Yeah.
But so far, no Avanto customers.
Yeah, I was thinking because we constantly keep switching on and off the timer when temperature drops below 5 or 10 degrees minus. We have to keep the pump constantly flowing, and when it's a bit warmer, then just the timer keeps track of that. I was thinking that maybe a surface water temperature sensor could just control the pump.
Yeah. So that's actually one thing that I kind of forgot to mention. Actually, a big oversight is that Lorawan is two-way communication. So not only sensor measurement data, but also you can also do control with the data. So it's possible to use either totally local controller or a temperature sensor that sends the temperature and then to the cloud, and then the cloud tells the relay controller to turn on or turn off.
Mm-hmm. Yeah, that something like that would work in this case if suitable sensors were available.
Yeah,
a floating temperature sensor.
Yeah, and I'm actually thinking that there is a very good chance that you could have some benefit of these satellite-based IoT systems because you have customers that are in different countries and around different areas, and if your customer does not want to have to think about the location and they want it to function anywhere in the world, in the middle of a sea or middle of a desert, then that is a very, very good solution.
Yeah, but like you know our customer base, so
yeah,
you also know the amount of pioneer attitude towards networking and throwing the data around. So even though it would be really nice to try to implement something like that for them, but it's many years to come before they start opening up to such, even for wireless communication that they don't control fully on their own.
Yes.
But that being said, there's always the industry side that is also interesting, and on that business area there might be something, especially for perimeter monitoring and certain values, and then also some sort of easy go there, measure something for a couple of days and come back with the devices, or leave them there if they're cheap enough. So type of activity. But other than that, those from the like the real professional side, it's a bit too conservative market.
Mm-hmm.
for the time being.
Yeah, we have had some like we have several customers that are actually like reseller customers, so they have a white label version of SuomiConnect IoT, and then they are kind of selling our systems, and then also some of them are renting the sensors or leasing the sensors to their customers, and some of these customers that have been wanting to just rent the sensors are these kind of consultants that are doing this ongelmakohde selvittely. So these air quality sensors, they so our customer has bought, say, 10 units, and then their customer wants to rent 10 pieces for 2 weeks or 1 month or something to try figure out what's wrong with some building. And so they can just go there, place them into place, and then measure for a few weeks or a month, and then send them back to the company they are renting them from.
Yep.
But that's one big advantage of the IoT is the flexibility. So, and with the fact that these are all so standardized, I have an example of one. There was one company called one company from Western Finland called Esinaden.net, but and they had a product called Hälyri, and so they're doing pretty much the same thing as one of our applications, this Mökkivahti, but for some reason that company just disappeared, and they didn't tell anything to their customers or anything. So now some of the customers have been contacting me and asking if it's possible for them to send their sensors to me, and then I reprogram them to use on our system, our Tinksi platform, and then send them back. So we just did that with the first customer, and it was successful. So they're very happy. So it's quite nice when you don't have to, if one company just disappears like this one, or if another company is if one company is getting bought by another company, then you don't have to throw everything away, all the devices away. You can simply reprogram them if you have the keys and the software. And, but yeah, so now we have actually contracts now with three satellite IoT companies, and satellite IoT is not it's not competing with regular terrestrial IoT, but it's complementing to it, because satellite IoT you have obviously you have more costs and higher latency, but the costs are not actually so terribly expensive, around €5 per month per sensor, compared to €2 per month with Lorawan sensors, and that's if you just have one or like several, maybe some tens of sensors. But then when you have more, when you get up into the higher number of sensors, then the price per sensor also goes down. And this our system, the SuomiConnect IoT system, is fully integratable into traditional automation systems. So For example, we use software called Advice, and this Advice software is used for running factories or buildings, or this example here is a hydropower station. But all these IoT sensors are easily integratable into these automation systems through REST API. And yeah, obviously we have all the different alarming systems like email alarming and SMS alarming and push alarms on the applications. But yeah, in essence, what IoT enables is, and especially when you're working with an IoT and automation company, you get the benefit of getting both systems in one. One problem that there has been with purely software side IoT houses is that they don't know about how motors and frequency controllers and proximity switches and all these different machines in a factory are actually functioning. And so when they are applying IoT to a factory, they come in and they just pretty much say, okay, here is the sensors, put them on your machines, and then they will measure your data. But when working with a IoT and automation company, then you get a lot more out of the actual technology. And so does anybody have now? Oh, yeah, I just realized. Or do you see my screen currently now?
Nope.
Hi. Okay. Yeah, sorry about that. I had intended to show to be showing this, and so this was when I was talking about the integration into traditional automation systems. And, so the IoT systems are very easy to integrate into these systems, and with IoT systems you can get a lot of data very quickly, very easily, and very at very low cost, especially when you consider the lifespan of these systems. And so I guess the last thing I was going to touch on as a kind of a bridge over to the next workshop, which will be run on artificial intelligence by Ulysses, is this Edge ML, and I was just thinking I'll show you my favorite player in this game. It's a American/Dutch company called Edge Impulse, and they are kind of well, I guess you could say pioneers, but they have the lovely open system with simulator for simulating your own systems. So you can simulate different kinds of edge machine learning chips on their system, and you can also simulate different machine learning programs. So-called tiny ML or tiny machine learning. So it's tiny machine learning is designed to happen on the edge on the devices. And edgeimpulse.com if somebody has an interest to read through their documents or watch their videos. But they have this thing to try it now, which is quite fun also. But yeah, so yeah, I guess that is the conclusion of this workshop here. And if my email, I guess everybody has my email address already, but it's marko@suomiconnect.fi. You can also find me on LinkedIn, and can also send this this material if you like, even though this was more just like kind of a frame for talking on. And so does anybody have any more questions now before we end?
One technology related question I have. Just thought of a maybe possible or plausible use case. How is the penetration of the signal in for instance in a shelter environment with thick concrete walls and stuff?
The signal penetration for Lorawan is actually quite good. It's because it's low frequency or relatively low frequency, 868 megahertz here in Europe. But that would be something that would be easy to test.
Well, in this case, easy to test, but anyways.
yeah.
But yeah. Mainly I was thinking because we may need to integrate some milliampere devices, both control and monitoring in a local scale. I mean, would have the gateway endpoint within the same shelter also.
Yes, yeah. So that would be no problem if the shelter is not say over a few kilometers.
No, it's not. No.
Then that would be no problem. They have tested penetration down to I think it was 13 basement floors in some building in China.
Okay.
And so that was with the gateway being on the first floor and the sensor down at the 13th, or maybe it was the 12th or 12B, as they don't use the 13 and the 14, but anyway, it was the 13th level down.
Okay. Might be interesting to think if that would be suitable. But good to know. Thanks.
Yeah. Mari, did you have any questions? If you like, you can take them in English or. Or French, or whatever you prefer.
Yeah, we can figure out what language to use. Let me kind of try to conclude my ideas. It has been very helpful. Like I just need you to be very patient with me, because I was just thinking that I think I had one course of physics in secondary school, and after that, none. And that was a couple of years ago. But yeah, there were so many things that I think could be very applicable to what we are doing at Nanopar. So maybe we talk about that later in the next webinar as well. I think it was very useful, yes.
Okay, great. Thank you. Okay, so Kimmo or Mario, do you have any questions at this stage?
No, can you hear me?
Yes.
Great, because I tried to speak earlier, but my mic was on because I have these headphones right now. Not many questions, but I take the opportunity to present the next workshop within 2 weeks. We didn't want to send this invitation to this workshop earlier so that we don't mess too much with these 2 workshops, but we will be sending these invitations today. And this workshop is more of AI, I guess, and Ulysses is playing the main role in this workshop, I believe.
Yes.
So you will and Mari also are very welcome to this workshop, and we will be inviting you and other persons later this afternoon. So thank you very much, Marko, for your good presentation and workshops. Shame that there were so few people, because the information was quite valuable and useful, and maybe we'll be in touch concerning that question I sent in the chat.
Okay. Wonderful.
Yeah, but so far, thanks to all for participating from my part and the Sata-hanke part, and we will continue offering interesting workshops to you in the future.
Thank you on my behalf as well. And Mari, one thing that I did not mention is that we also do development. So for research projects and different kinds of development projects, we are always very interested in working together with companies on developing new technology and new methods.
Yeah, this is good to know. Well, so far I can just mention that I talked about this with my boss already, and I guess the most crucial thing is sort of remote troubleshooting, because the process is automated and it's used remote in most of the cases. But also, like those things you already mentioned, like how much space there would be in the container to control that. And personally, I'm also really interested about sort of the soil structure or the sludge structure. And I don't know if it's like possible at all, but also to see kind of what nutrients there are, or what is it in the sludge. I don't know if that's possible at all, but
yeah, well, for example, measuring things like pH and conductivity and NPK, these are very possible.
okay.
But I guess you can tell me more information about this later on.
Yeah, well, I'm sort of a messenger here, so I try to collect the information from those persons who actually know about the technique, and then trying to collect the information from you, and then I think at some point I have to sort of collect these people together, and you can talk directly to each other. So it's more practical in that way. But at the moment, I'm sort of the messenger in between.
Sure.
Yes, I want to mention that it may be possible. Mario is our budget keeper and project manager in this Sata-hanke, but maybe it could be possible. We must count our money if you want to do a pilot or some demonstrations to use Sata-hanke budget in that. But we must count the money or Mario must do that. And we will have a meeting with Mario soon after this workshops. So, but please keep that in mind also. It may be possible.
Great.
Yeah, great. Yeah, I hope.
Okay.
Hopefully this Corona will go away, and next time we can do live workshop, because I'm much more of a live workshop person.
Yeah, but it was nice that you presented those sensors. Unfortunately, we didn't get the opportunity to touch them and handle them.
Yes.
like usually.
Yeah.
Kierros, hypistelykierros.
Yeah.
But maybe in the future after the summer holiday or something like that.
Yes.
Okay, thank you very much all, and have a nice day and nice work week.
Thank you very much.
Thank you.
Take care.
Yeah.
We will
Same
be
to you.
back.
Bye-bye.
Bye-bye.